Hi, thanks for coming. I'm honored that I got a slot here at late notice. I'm Emacs, follow me at Emacs on Twitter. I'm going to tell you a little bit about things I've been thinking about in terms of long-term data use. This is what really keeps me awake at night. I think that a personal anecdote is that this all started about 10 years ago when I visited my grandmother. I'm American, by the way, fearlessly American. Eva was talking about Americans have a perspective, but I've been here sufficiently long that I've been reprogrammed. And that I'm one of the good Americans, as she would say. And I visited my grandmother and in Boise, Idaho, which is a place you don't need to know where it is. Google Maps it will tell you. And she brought up she basically has this archive of photos dating back to the 1830s, which is, sorry, those were not photos. She had documents from the 1830s, and she had photos from the early 1940s, 50s, 60s, and it was amazing because I can't even find the photos I took last year. And so this sort of brought me up to sort of thinking about why this is the case. Here's what my talk's going to look like today. I was going to skip the first one because we all know why we're redecentralizing, but I wanted to sort of actually react to something Eva just said. And so I put in part 0, which is a prequel, which is why we're here. The first one, which is the really why we're here, is going to talk about the needs surrounding long-term use and access. And then I'm going to start talking about how we might evaluate the kinds of cool technologies that we're developing and thinking about in terms of whether they actually satisfy the needs that we identified, right, that we are identifying as a community, okay? And then the last thing is, the least significant thing I want to talk about is at the end, which is our own efforts within our research group on our own sort of set of specifications and ideas around recentralizing the web around people. And this is in contrast to some of the approaches that you guys are talking about, where you're talking about completely going fully decentralized, these gigantic decentralized and cool systems. I think they're cool, and they definitely will have an important role to play, potentially, in a lot of kinds of services and applications. But I think that for people, we really want to have something that's under the control of an individual. Hopefully you'll either believe me or you'll violently disagree by the end of this talk. So the thing that I wanted to react with respect to what Eva was saying was that she was talking about Tim and his architecture of the web. And she was saying, sorry, I'm paraphrasing what you just said, but that he was essentially apologetic or about how this sort of client-server model. And I disagree. I mean, I hang out with Tim quite a bit, but usually when we're drunk, because it's the best time to do that. And the original model of this client-server of the web was not in the way that we have today. Instead, his idea was essentially that everybody in his certain lab, and the world was running a server, right? So because, why wouldn't you run a server? You have a computer, it's connected to the internet, right? So this was one of the early, extremely, authentic, original illustrations of the web. They were like, well, if you wanted to share something, you hosted it on your computer, and then somebody would just get it, right? And that was the web, right? But somewhere along the way, we ended up with this. And actually, it's been hugely successful, right? We might be talking about this. This is interesting because it's sort of a bit of a time lapse here. But the web has been hugely successful in its decentralized manner. It is a decentralized system, right? And so, if we're talking about the number of distinct hosts and websites, they keep going up, in incredible rates. But why are we concerned? Why are we so worried as a community? And the reason is that while there's a huge number of hosts on the web, there are only 4 that matter. And that's because people spend an incredibly disproportionate amount of their time, energy, and resource on those 4. And so why is this a problem? Well, again, this is the part 0, that we already know this, right? So one of the reasons why this is a problem is that it grants incredible power to those central nodes, right? And so if you have all of the world's population on a single website, in a single database, then you can do really amazing things, such as manipulating people's emotions without telling them. That's one of the problems. Other problems include if you want to completely recreate history, you can do that because the records of history are held by your own database. So the thing that's really disturbing about the right to be forgotten ruling, which I think is a really interesting recent development, is that it only concerned Google, right? And so you're like, if you're not in Google's database anymore, you're forgotten. And that is the alarming bit of the ruling. There's many other implications of the ruling, but that's the thing that really got to me. So whenever we have these centralized, essentially services, specifically those that are commercially driven, then you have this interesting situation where you have a problem of incentives, right? So people go to these services because they need or want something. And the services provide those affordances, those capabilities, because they want to attract people to use their services, but also because they have other incentives in mind. So perpetually, we're never going to actually get services that do all the things exactly in the way that people need them without some sort of extra vector of motivation. And that comes in through this. And so that's the observation of what happens when you have usually sort of centralized organizations that are for-profit that are driving the entire set of tools that we have available on our daily basis. So an analogy that I used is that it's a bit like living in an IKEA, right? There's a huge sort of drive for IKEA to bring you into the store and to let you get very comfortable, and they provide lots of services for doing that, but you never really own anything around you, right? And you're only allowed to do things inside your environment that sort of falls within the confines of what benefits the space or the host organization that provides it. So what does it mean? So this is all background information, right? So what does this mean for the normal end user, the normal individual? People are perfectly happy to live in IKEAs most of the time. But now I'm going to shift to the second part of the talk where we say, actually, IKEAs may be comfortable for the short term, and the meatballs may taste good. But if you keep eating those meatballs, right, your long-term interests are not necessarily aligned, right? And so look at these very happy people who are getting on the tube here. You can see it's London. Everyone's so happy to be there. Okay. So, and those three things, those three problems, those three issues, I believe, are around long-term use, archiving and access, 2, privacy, if you're American like me, and repurposability. And we're going to go through these in a little bit of detail, okay? So, these inspiring quotes. As devices come and go, you persist. Actually, Satya Nadella said this last week, and this was kind of surprising to me because he makes Windows devices, right? He makes devices, right? And so but one of his major pushes is to say, look, people's personal information spaces actually transcends the device that they run on. So he's using this as a motivation for Microsoft to get more into cloud services, I believe, right? But fundamentally, the same lesson that he's saying, I think we can transfer to what we're doing is that you can't fall in love with this one thing becoming the hub for all things for all time to come. And I think that this is a very interesting thing with respect to a priority, which is to allow people to have some autonomy with respect to making things. The only thing that doesn't change is change itself, right? You know that things are going to be changing constantly. Specifically when you're talking about the scale of half a decade, if you're talking about a decade, then everything is going to change. And as a result, we have to think about designing for that. And that's really hard in the world of bits. In atoms, it's not so hard. As I've discovered recently, joining Oxford University last month, I got access to the Bodleian, which is one of the eminent libraries of the country, and they are the official depository for the UK. So they have a copy of every single book published in the UK after a certain number of years. But what's incredible about this place is that they've got the medieval library, and you go in there, and everything is perfectly in order, right? And a lot of brilliant things were written, 1,000 years ago, and it's still there, it's available, it's accessible to anybody who wants to get it. And so with Atoms, we sort of, at the scale of a library, we know how to do that. Even at the scale of our own personal environments, we know how to do this. We actually, we can put things into secure lockers. We can put them in our basement. We can actually make physical printouts of them. But then when it comes to bits, things become a lot more difficult, especially as we end up with a pile of these things around right now. At least they'll end up somewhere. But now we're getting to the point that we don't even have a pile of those things anymore, right? And so I used, those things, which you can swallow or lose in other ways, at least there's some hope that you'll be able to find them or preserve them in some way. You could put them in an icebox and hide it somewhere. But how do you preserve your iCloud? There's really no clear answer to how you do that. And so I'm going to skip through this is part of a longer talk. One of the things that people keep talking about in electronic medical record space right now is the notion of cradle to grave. So I want to take apart this notion of cradle to grave. It's a sort of a buzzword that people in the electronic medical record community are talking about, because they said, we want electronic medical records. When you're born, you get your first EMR records, and then you build it up as you grow up. And then when you hit middle age, you start developing chronic conditions, these things go in there, and all the way, and you live your happy and productive life until and you ride the tube a lot, and then you end up, passing away, and you have this consolidated medical record is the kind of image that they're talking about. So in order to do that, they say, just use our company, it'll be great, right? So let's just pick that apart, okay. So the UK life expectancy is currently 80 years, okay? The entire history of personal computing is 37 years, okay? So in that time, what has happened in 37 years? Well, basically everything, right, for personal computing, okay? We've learned how to store files well, we really didn't know how to do that very well, right? We've developed hard drives, those are good. We've developed graphical user interfaces. Things move dramatically from being very sort of, physical storage to things where, essentially the media that we use to store data changed fundamentally, and the physicality changed fundamentally. And so we just have to say, if you're talking about a system that's going to actually work cradle to grave, then we need to start over and think very hard about how we're going to make that happen. I know that there's a lot of people from the States here, and a lot of people from really cool organizations in the UK and in Europe. And I think that there may be somebody from the Long Now Foundation. Anybody from the Long Now Foundation here? There might be some people from library systems too. There are people working in properly in preservation of data who I would love to talk to about this stuff, because specifically when you're talking about a huge range of different kinds of structured and unstructured data, there's a lot of challenges with respect to readability. Just think about trying to read your Word documents from 10 years ago. Okay, second theme, privacy. Is that all right? By the way, you can interrupt me, jump in, feel free, and then hopefully everybody will sort of throw things at me at the end, and then we'll have a great discussion. Okay? Okay. Sorry, I have no idea how my time's down. Okay, so privacy.
25 minutes.
Okay, great. So privacy is a very interesting thing. So, but I want to talk about one aspect of it because it's such a broad space. And that is what's happening right now, especially if you are fancy and buy these things for your house and believe in this notion of this Internet of Things. I, for one, already have sensors on my body that measure what I'm doing, my heart rate. It's probably elevated right now, slightly. And in our homes, we also have environmental sensors. And these things are all incredibly useful and cool devices. And they're generating huge amounts of data about people's environments on a minute-by-minute basis. One of our research projects is determining whether we can use this data to help people in clinical condition management. For example, there's lots of uses, right? So it's cool. However, an interesting thing about how these things are developed is that they're all designed to, first and foremost, send all of their data to a third party, which aggregates them. And you might not think that the temperature of your room is very exciting, even over the long term. But there are also sensors like this, which is the Nest Dropcam, which was just acquired by Google. What's great about Google is that they're very fast, they quickly converge on dystopian sort of scenarios. They're extremely efficient at going from concept to reality in terms of your worst nightmare. And so you have this wonderful little, yes, get this cool drop cam, because even when you're miles away, you can keep an eye on your home, your kids, right, and your mischievous pets. I don't have mischievous pets. So you can know that 24 hours a day, Google's watching. And they're great about integrating their data with your other services across the Google ecosphere. And so, and bringing it up to you to creep you out in Google Now. So it'd be like, I see your kids. They're smiling. So this is of increasing risk, right? Because what we're doing is these companies are all fighting to become the join points for sensor data. If one stream of sensor data is marginally privacy invasive, if you intersect all of these streams of data together, then you get something that's potentially extremely privacy invasive, right? And the saddest thing is, in addition to this, they don't really let you do what you want with that data, right? So they provide you some basic apps and things like that, but ultimately what they're able to do is they're able to use the data for their own incentives, their own purposes. So I'm going to pick on another service, which is really interesting. This is a service, If This and That. Who's used If This and That? It's a really cool service, right? And what it allows you to do, for those of you who, it seems like the majority of the room, you guys must be nerds or something, or use it. It allows you to set up these web scripts, which lets you essentially automate your home by setting up triggers. So when you say, okay, when I get home, let's wait for the screen to update. Okay, when I get home, if my location is somewhere, then do this for me on my other device, okay? And this is cool because it links together. They call it they get excited and call it the operating system of Internet of Things, right? They allow you to intersect multiple streams of data, and it actually shows you that when you get some sort of coordination among things, things become way more useful than just measuring the temperature of the room, right? This is how we used to build computer systems, right? Compositionally. You used to build a thing that when you added it to a system, everything could benefit from the system and use that thing. Somewhere along the way, with the apps model, we lost that, right? Now you add a new thing and it just sits there and does its thing, and it doesn't help anyone else. But If This and That shows you the potential to do things, do these kind of combinations of things, so that you don't have to worry about them yourself. What's the problem? What's the problem is that they're an intermediary, right? They're a third-party intermediary, and what's really annoying is that they require access to everything in order for them to trigger those things, right? And so, as a result, they're like, oh, look at these lovely connectors. Authorize us to get access to your American Express card, and your Best Buy account, and your Office 365 calendar, and 40 other things, so that you can sort of automate your home. And I'd be like, I can't, there's really not even beginning to say how much nope there is in doing that, right? Because what you're doing is you're granting people access to this intersection of all of these things in a single space, right? And so I want to return to, so those are three sort of stories that I wanted to give you. And I want to return to the principles of what we want to achieve. And the first is autonomy. The freedom to do whatever you want with your data and to determine sort of how it's done and with whom, okay? And so this is interesting because the if this and that is a great example. I want to be able to automate things according to ways that I want, right? But I want to do it in terms that are under my control. Say I want to do it on my machine. Or I want to do it on the university's machine. It doesn't have to be mine. Or and the second thing, which is I think one of the biggest things that I think we don't know how to do yet is responsibility. So one of the ways to ensure that your data stays around for a while is to take responsibility for it. Instead of abdicating this responsibility to some third party saying, oh, they'll take care of it for me for my lifetime. If you really care about something, you take care of it yourself. And it's a question of how do you do that. So if with great power comes responsibility, then with great responsibility comes great power as well. And then the third thing is control. So we never say, I want to control my car today on the way to work, right? But the notion of control is extremely interesting in terms of, now this slide was made before smart cars were really popular, but we have a notion of what it means to be able to control your information, and we'll talk about that in just a bit. So let's quickly, sorry this is a lot longer than I expected it to be. So this is where you can attack me about how I'm characterizing these systems. How well do these new decentralization architectures support these needs that I'm talking about? So for fun times, I'm going to pick on 4 systems today, and that's Ethereum, MateSafe, Maelstrom, and IPFS. The reason why I'm picking on these 4 is that they're all cool. 1, they're really fun systems. 2, they all call themselves saving the web, right? So all of these things claim to save the internet or save the web through redecentralization. First thing I'm going to ask about these systems is whether they're safe. Okay. So who owns the system? So if we're talking about the 80 to 100 year problem, who owns it? And that's a 2-part question, the code base versus the IP associated. And if they're a commercial entity, then what is their incentive for providing that service? And moreover, if they're a commercial entity or a nonprofit, will it exist? So will it exist are they likely to continue existing even if the organization behind it fails? Okay? So unfortunately, that immediately kills one of them, right? So Maelstrom is a commercial offering by BitTorrent. And BitTorrent does not play. Anybody from BitTorrent here? BitTorrent is a famously evil company. And BitTorrent, you think, are the authors of the BitTorrent protocol, but they're not. BitTorrent, the open protocol, was proposed by our friends at the Pirate Bay, Peter Sinde and a few other people who tweaked it, introduced improvements. BitTorrent, the company, took those improvements, modified them further, incorporated them into their commercial offerings, and then did not republish these changes. And now they want to save the web through this BitTorrent-based browser stuff bunk, right? Not going to last. No one's going to use it. Closed source. No. Okay, next. So will it last? Okay. So second question is, will it last? And that's a very interesting thing because one of the key questions with respect to supporting, I don't actually know what's up here, lasting over time is whether something can be evolved. This is a question for you experts on blockchain-based architectures and things like that. So some systems that can evolve, like for example, the space station, is that it's a hypermodular architecture. So things are designed to be removed and added over time to evolve so that it can last 25 years. And if we look at the web is also another modular architecture, in that if you could take little bits of it, change them without breaking the entire system, right? And if you look at every single bit of the web over the past 25 years, it's changed significantly, okay? And that's really what's allowed it to grow. So my question to you, which I don't know the answer of, is what about Bitcoin? Is it going to be incrementally evolvable? What about Ethereum? These are quite complicated compared to the web. And so, maybe not. Maybe it is evolvable. But it's a very important property of systems that last. Okay, if you believe me. And then, okay, another property which is very interesting. which I completely arbitrarily came up with, is it partitionable? Okay, so partitioning with respect to, does it work during the apocalypse? Is the question. Okay, so as you know, when the terrible earthquake, Tohoku earthquake happened in Japan, the entire region was without internet access for a while, and part of the reason why some of the support for the nuclear disaster was not able to be coordinated was a lack of connectivity. Okay, but if you do provide infrastructure that doesn't need centralized infrastructure, in other words, if you have things that can talk to each other without central infrastructure, then actually you can save lives. And people have been talking about making the internet better by making it resilient to those kinds of catastrophes. What I don't know why this has not had more work on it. Perhaps disasters aren't lucrative, I'm not sure. But this is a huge property, right? We need to be able to do this. But there are other reasons, day to day, that being partitioned is important. So we are more often partitioned every day than we think we are. Every time we're traveling on the tube, since we can't seem to install Wi-Fi or 3G in the tube, or when we fly places. But also, the partitioning is a very interesting strategy, okay? It's a strategy that my grandparents use inadvertently because they keep getting kicked off of their DSL provider, because the DSL provider, they forget to renew their subscriptions to things and things. But it's a very interesting strategy for stopping change, right? So if your system's like, I'm going to upgrade you to Windows 10 without telling you, this is great. If you just partition the system, then it wouldn't have done that, right? So anyway, this is a very interesting property with respect to, do some of these decentralized systems support partitioning? And if not, why not? I think they should. And the final thing I'm going to talk about is it generic enough? So and this pertains to whether it's actually a platform or an application. If it's a platform, then it should be able to do all sorts of things without modifying the underlying plumbing. But the reason why I feel that Bitcoin is more of an application than a platform is that every time somebody wants to make a new application or new modification, they go off and make a new cryptocurrency or new proof of work based architecture. They go back down into the plumbing to modify these things. And this is a warning sign to me. Because you know what? I'm old school, and this reminds me of the internet before the web. This reminds me of when I had to go for IRC and do all of these separate things, right? Use different underlying plumbing on top of the internet in order to access information. The web got rid of these distinctions, right? And so are we creating a bunch of these little one-off applications, or are we creating robust infrastructure? Again, this is why I was worried people were going to throw things at me. Maybe I'm completely wrong, so love to. And the last thing deals with, again, we've already talked a lot about control. But control is a very nuanced thing. It has many kinds of applications. The control, again, is if we're providing people the means of migrating information, of controlling who gets access to information, then it has to be really easy and it has to be simple. And I think we all can agree with that. So the last part of my talk, sorry about, we have a few more minutes. Are we okay? 10 minutes, okay. Is how we might do this using existing components. So I'm not a good baker, so if I were to make pies, I would go and get oh, by the way, this is a very English view of the world, so we're making mince pies today, okay, so it's almost Christmas time, right, so I thought it would be seasonal. So let's start with a scenario that it's like, okay, say that I'm going to use a suitably, English or Irish name here. So say that our friend Kieran wants to host a League of Legends fanfic site. So he's like, hey, so many people are LoL fans, so I'm going to do this. So, but he's sort of, I wouldn't call him a techno-numpty, but he's a League of Legends guy, right? So he doesn't know anything about hosting stuff on the web. But he heard that if he buys one of these cool gadgets, which is kind of shiny, and then like puts this sort of self-hosting stuff on it, that it would work. And so he bought this for like 100 quid. It's a fast x86 machine. And he knows that much, and he bought a flash drive that has the Sandstorm stuff on it. And he goes and sets it up, and it works, right? It works, but then as soon as he tries to share it with his friends, then he encounters two really sad things, which people already talked about earlier. One is like, I have to go and register a DNS, thing. Why do I have to do that? It's not, and why isn't it free, right? He's used to things being free. And the second thing that's even sadder, right, that he just can't get around, is the fact that he has a really crappy internet service provider, and it doesn't have a static IP address. And so he's like, and he probably hasn't even heard of DNS. Probably didn't, but DNS is not an open standard. It's a closed company, a centralized company that provides this dynamic. So he starts crying, right? That's the end, right? So let's save Kieran, right? Okay, so what is PIES? So this is in reference to Philomena Kunk's What is Clocks, which is the best episode ever of Charlie Brooker's Newswipe. So what is PIES? So we want to return to the idea that everyone can run a server, just like Sandstorm, just like Cozy, and all you wonderful people out here who make these platforms. And we want to add useful support to them in a modular fashion to overcome things that make Kieran sad. Okay, so this is a sketch that doesn't exist yet, so I'm a little bit hesitant to talk about it. I mean, it doesn't fully exist yet. I'm working on it. It's called Inception, and what it is web inside the web. And the way that this will work is the following. So this provides 4 things: naming, routing, sorry, I turned American for a second, availability, and resistance, okay? So Kieran's been replaced by Donna now. Okay, Donna. Donna's she's a bit of a nerd. She wants a microblog for fans of JavaScript. So what she does is she goes to a website which provides a server implementation, right? This is the source of the server, and it can be hosted on GitHub pages, okay? And that instantly loads a server. So she knows that she can run that anywhere. So she actually runs it in a browser on Chromium on her Raspberry Pi 2, which is a really great piece of hardware. Then she goes, okay, I need a name for this server for all my JavaScript nerds to access, right? So then she goes and she registers it with one of these free and open decentralized, basically registrars. This is a problem, right? We really hate DNS. DNS is the enemy, okay? But we can't change DNS. So one of the ways we can make it less evil is to make open things that let people create these central hub things that essentially provide free registration for everybody. And it's going to do a second thing, in addition to providing organic naming. It's going to provide an on-ramp into WebRTC space. I'll tell you why in a second. So by going and registering at one of these nodes, she goes, all right, so my new JavaScript blog is going to be, sort of incept.io/JavaScript nerds. Shoot. And that's it. And what happens is, as soon as people go to that website, what it does is it actually tunnels the request to her browser on her Raspberry Pi. That's all it does, okay? And that Raspberry Pi returns, it's an HTTP server inside the browser, okay? And so what that does is that's why it's called Inception. So then everything is controlled by her server, which is cool. So that's a sketch of something that I didn't invent. So that is something that was inspired by Peer Server, which is a little hackathon project that 2 undergraduates wrote at Stanford. Really great system, and that I've been playing with. Okay, so I'm thinking what we could do then, and this is where I need your help, is so that sort of solves sort of the naming and routing problem. But if you have better ideas about that, let me know. If there are people who are Tor heads in here, Tor is incredible, right? And one of the things that Tor provides is global naming. So you get an onion address that doesn't change regardless of where you are, okay? The problem is you can't run Tor in a browser yet. You can't run Tor in the browser yet. You can get Tor browser, but you can't run it in the browser. So love to talk to you about that. The second thing I want to talk about is social data responsibility. So the problem with running it in a browser is that you might close the browser, right? I mean, whoops. And then you might clear the browser cookies, right? So whoops, right? You might lose your data. So I would want a protocol. I want an extension to Solid, right? Which allows you to say, okay, I'm going to have a mirror of all my grandmother's stuff on my data center at home, which I do have a data center at home, because my grandmother can't be trusted, okay? Or vice versa. Maybe she can be trusted, and I'm the one that lives in a ghetto part of Oxford, which is possibly true. The third thing deals with migration and consolidation. This is non-trivial, so we need some method of taking data out of things and putting them into other things. In particular, getting data out of things that are not yours into things that are yours. And the last one is sort of weird. I don't know if I have time to talk about it, but basically is the notion that because there's a lot of work in managing your own data, maybe we could talk about ways to make that less painful. And one of the things we're talking about is, and this is, you'll see coming out in the next half a year or so from our group and others, something called executable or enforceable data terms of use. So you can give somebody an entire high fidelity record of your health kit data and say, you can use this for such and such things, but not for such and such things. You can use this but not transmit it to Edward or somebody. And what it does is it then goes and helps you to follow within the rules, provides accountability for that, and then anyway. So there's a lot of interesting things when you deal with decentralized contracts, and I think there's a lot of work being done with Eris and a lot of other proof of work stuff dealing with social contracts. I think that's a great idea, and we can do that without the blockchain. Yeah, I guess that was maybe the last slide I got to talk to you about. So let's talk too long. Thank you for listening.
Questions?
Yes, questions. Attack me, please.
Just wondering if you could go into more detail about sort of the possible solutions for naming and routing and whether, thoughts on attempts to use blockchain to do that, why that would work.
Actually, it's really cool. So one of the possibilities. So the question was talk a little bit more about naming and routing and whether we could use whether you do the blockchain like architecture to do that. I think that's a realistic possibility if we can support partition operation of it. One of the things that scares me about blockchain is that it requires global consensus, right? And I want user consensus. Essentially, if I agree that this is what I call this thing. But then you end up things when you merge isolated worlds, you end up with problems with it. Namecoin and IPFS both do a really cool thing about solving the organic namespace problem, which is it's a really great idea. But essentially, you generate a random key pair that you hide, and then you hash that. You basically publish your public key. Right? And it's very unlikely that two people within the universe would have the same public key. So that's a really neat way to grow an organic namespace. And then you can easily prove that you're the owner of that name. That's basically all you need for naming, right? And so blatantly stolen from IPFS, I think that's a great idea. And then the question is, routing is a pain in the butt for a lot of reasons, especially when you're talking about potentially partitioned namespaces. I'm not an expert on that, so yeah.
Who else has questions? I've got a mic in the hopes that we record some. I have a quick question, which is if you had the IPFS Ethereum and name saved there, and then you went through what is it that you're looking for, how did they do on your requirements chart?
Well, okay, so
they do pretty well.
Well, maybe they do, and that's what I want to hear from you, because I want to know.
They're all open source.
They're open source, which is really cool. Do they provide control? Do they provide partitionability? Do they provide evolvability and autonomous, essentially, migration of things? So I don't think the answer is no. I think the answer is probably in some ways yes, right? And the question is, does it, for example, with blockchain-based architectures, it might not make sense to have partitioned operation, right? So how do we build an architecture such that some of it has to be globally, support the sort of global stuff, but some of it will also work in disconnected? Because we have to realize the needs are pretty significant with respect to providing disconnected operation, providing autonomy. And so I think that the answer, is in the current state, none of them do. But neither does anything else. So that's talk about.
Anyone have any last question before we break for lunch?
God, I talked for so long, I'm really sorry. I intended it more to be a discussion, argumentation.
No, Max, thank you so much.
Thank you.